Leaders tend to look for big new ideas. Managers tend to replicate what's considered best practice. If you just copy, you're just managing your stuff. You're never going to be a leader. So you not only have to ask yourself what people expect, but also what people do not expect. So what do customers expect? Customers expect that there's a Coke wherever they are. That's why there's Coke machines all over the place, and there's definitely a machine or a Coke within 80 meters of all of you right now. There's actually one there, and there's one here right there. What do customers not expect? That you'd have drones deliver them. If you have drones deliver the Coke like they did in Singapore, people take photos and they go, oh my God, epic, I want one. You have to ask yourself, what does the competition expect? L.A. is a car city, and obviously everybody is now thinking about self-driving cars. I was at the largest computer fair for non-consumers, for business to business, called CeBIT, and the biggest booth was IBM, and the second biggest Volkswagen. Because Volkswagen now thinks that they have data on wheels. It's all about data. And Volvo is doing self-driving taxis and stuff like that in Göteborg right now. So everybody's working on self-driving cars. So self-driving cars is what people expect. But what do they not expect? And they do not expect that you completely consider it big data on wheels. That's what Google Car does. Google Taxi considers itself big data on wheels. So Google Taxi knows whatever you Google and learns whatever you Google. So Google, if you use a calendar, like a Google Calendar, Google Taxi knows that you have to be at work or at a certain meeting 30 minutes from now. And Google Taxi will drive to you and wait for you. And Google Taxi will know your favorite music and all the porn you look on YouTube. Google Taxi knows a lot more than anything or anybody in the world, and it can totally individualize that information. Google Taxi also knows when you're looking for, searching for recipes with salmon. And when you're then driving to your meeting, Google Taxi knows that salmon is on sale in a certain place and is already ready to call them so that the car pulls over, they run out, give you the salmon, you already pay with PayPal. Oh, you know what, your friends, I know who you're meeting anyway. I'm just going to tell them that you're going to be 3 minutes late, and I can show them the, the porn you liked so much on YouTube. And share that information with everybody. That's a complete, nobody expects that, but that's what's going to happen because this shit is happening. So then you have to ask yourself, what does the market expect? And the market expects, in general, things to go smoother and things to go faster. That's just the tendency. If you have a solution that's slower, it might be interesting for a smaller bracket of the market, like slow food. It exists, but the large portion of the market prefers fast food. So the large portion will go for the faster solution. That's why I think, you know, that last year in January, Amazon and Walmart had a big fight about e-commerce, and they didn't optimize their products or offered a wider range of product. What they optimized was delivery time. And that's why they started to have same-day delivery. And then in May, eBay did 1-hour delivery. And then we tried it in Brooklyn. It was 52 minutes in July. And then in September in Beijing and Shanghai and Shenzhen, it's 30 minutes. So stuff gets faster all the time. And the market expects that. If you don't get faster, if you have slower downloading, I have really slow downloading speed. It will not work, right? But what do the people not expect? And that's the killer that's before time. And before time, real time is good, but before time is even better. And before time is getting really, really big right now. So if you're playing golf, the machine knows when you will run out of golf balls, because that's relatively predictable, because it knows a certain pattern. Like everything, like from toilet paper or toothpaste to cat food and all those kind of things, you buy those things in relatively predictable time frames. So you get the information when you're on the golf course that you are about to run out of golf balls, and if the machine should simply order some for you. And all you have to do is press one button and OK it. So the smart thing about that is, A, that they know when you will run out of golf balls or toilet paper or toothpaste or whatever. And the other thing is that they choose a relevant context due to geolocation, which is the golf course. You don't get that information when you're at a funeral. although maybe that would be good. Epic, anyway, potentially. But so they know that you are at a golf course. That's why your brain is, synced into golf, and that's why this information is relevant. So before time is the new killer thing. So what changed for us other than that? Other than that, everything changed. We currently have over 2 billion smartphones on the planet, you know that, and by 2015, 40% of those will have near-field communication. Obviously, we're starting to wear devices, all kinds of things exist all the time, and they can even be individualized and know you, like Necomimi. Necomimi knows who you are and authenticates you, and that's why you can pay with it. It measures your heart rate, it's secure payment, and it works with near-field and stuff like that, so you never have to give in a code. If it works with near-field, it can obviously unlock all kinds of things like your car. And it knows that it's you. That's why if you go to a hotel, for instance, it's not an anonymous near-field thing, but it knows you. And the room knows that you enter. And the room knows your favorite temperature. And it knows your relatives. And it knows where you stop watching TV. Because it's you, and all those things you do are known and are in the cloud, so you can resume watching where you just left off because it's individualized and you're wearing this device. That's why people like Mindshare and stuff like that now launch a wearable device unit, because this thing is getting relatively big. These are input systems. Then there's obviously output system, Google Glass, and Google Glass obviously is growing and growing and growing. I gave a lot of talks at huge conferences all over Europe, and in Europe, if you want to win an iPad by giving away your business card, it won't work anymore. The times of being able to win an iPad are gone. You can now only win Google Glass. The Austrian military has Google Glass, and a lot of people that are not dealing with customers have Google Glass because it works really, really efficiently. I know there's a spookiness factor to it, but there's a lot of people that are pushing Google Glass, and here's a little example of what it can do.
Take a look at Miguel. He's interested in a pair of trick skis. Using a simple Hybris app, he retrieves some product details from a QR code and makes a request for customer service the next time he's in store. As Miguel walks into the store, a little piece of magic happens. Thanks to Google Glass, a couple of eye beacons and Hybris, Sarah, the sales assistant, knows that Miguel is in the store and exactly what he's interested in purchasing. We've connected Miguel's Facebook profile to the Hybris in-store app and displayed his profile picture in Sarah's Google Glass. At payment, Sarah notices Miguel has a pair of headphones in his wish list, and the skis have qualified him for a great promotion. Everyone's happy.
Everyone is happy. This again shows, and Susan and I were talking about that now the customer relationship thing is getting really, really important because it has to be built on trust. The foundation of all relationships is trust. So touch points become trust points. So if you just suck information out and have everybody, I don't know, transparent, that's probably not a good thing to start a relationship. Be friendly to your people. If they okay it, let them do that, but there has to be an exchange. I exchange data for service. But you have to do that willingly. Anyway, Google Glass is getting really, really big. You can now pay with Google Glass, and you can use it underwater. And Google Glass obviously is not the answer because it's ugly. And so universities are building lenses, as you might know. Startups are building lenses, as you might know. Google is building lenses, as you might know. Lenses obviously also not the end of the spectrum, because if you wore Google Glass, you know it's just this like idiotic frame right here, and it's much better to do what you did today and wear Oculus Rift, because Oculus Rift is the thing that Facebook bought for a couple of billion, is absolutely real and knocks your socks off if you're using it, as you can see. And that is another reality that walks with you. We will come to Oculus Rift later in a minute, but that's a much better thing. Oculus Rift still not the end of the line because there's in-between solutions like Glyph. Glyph is a regular headphone set. It's only going to cost $4.99 if Kickstarter is correct. And you can flip it down, then you look like this, and you can attach it to any device you have, and it will beam the image directly onto your retina. So it's not really a screen. It has millions of mirrors that directly beam the image from that machine onto your retina, and has, if Snoop Dogg is correct, because Snoop Dogg wore awesome picture. Still not the end of the things. Transparent emotions are getting here. Steve Hawking, as you might know, used to look at the letters, and his sickness got worse and worse, so he was down to 1 letter a minute, because it got really, really bad. Then Justin Redner from Intel and a bunch of other people bought a machine that can read his emotion and predict what he says. And that allowed him to be now at one sentence a minute. That's why Justin Redner said, we will be emotionally connected with our devices in a few years. You all know the speed of development. Obviously, it's not a few years. It already happened. If you go in England to any Tesco store or Tesco gas station, there will be machines that read your emotions. They know what sex you are, what gender you are, what age you are, due to facial analysis, and they will display ads made for you. Whenever there's a non-public ad, like in a taxi or in just waiting in line, this is relatively efficient. We tried it. And that's actually funny, because if you look sad and you're a woman, you get chocolate. And if you look sad and you're a man, you get beer. So it's smart. It's a really good, it's a smart technology. You don't need a technology that is outside of you. You can actually do it inside of you. This is obviously not invented by Google. That's why it's fun. I hope nobody from Google in the room. Necomimi, I don't know if you know Necomimi. Necomimi is relatively simple. You can see it here a little bit better. It doesn't look so good. It just takes your brain waves, and if you pay attention, the ears go up, and if you do not pay attention, the ears go down. So it's very easy. You pay attention, ears go up. You do not pay attention, ears go down. Paying attention or having active thoughts could be, for instance, think about playing tennis. And having relaxing thoughts could be, for instance, just think about relaxing at home, okay? I go back to her, she looks better. 5 months after this was invented, the first people connected Necomimi to wheelchairs for extremely handicapped people. So if you can't go like this anymore, you can at least think, okay? What happened now is that the scientific community, because this is basically a primitive medical device. So, but since when this was invented, the people that have the complex medical device came up with the idea, you know, this is basically yes, no, 1, 0. So you know what? We can talk to coma patients. So if you're a coma patient that couldn't even move the eyes, and you were vegetable for 8 years, it used to be like this. Boop. Then they pulled the plug, because no response. So now what they do, they put the medical version on the person's head and say, okay, if you can hear me, for everything that is yes, think about you playing tennis. For everything that you think is no, think about relaxing in your living room. Can you hear me? Yes. What's your father's name? Steve, John, Bob, Mike. No, no, yes, no. Oh. Shall we pull the plug? So Necomimi can measure stuff. The next step is that the machine measures stuff and then selects products for you, in this case music. Miko selects music. It's already, you can see, a little bit smaller. So it measures your brainwave and then it selects music. That basically means that you can see what you would need right now to stay in a certain mind. And if you think about things maybe getting smaller and being everywhere, I see there's no reason why you shouldn't be later able to walk through the city and create just by looking a wish list. So you will only get Christmas gifts you really like. Another tie. But maybe that's also a little bit scary. This is, however, not the end, because now you can obviously operate complex machinery with just by thinking. And if you saw the the soccer world championship, you might know that a paraplegic person, just by thinking, kicked the first ball. So it was just thinking. And then the machine translated the thoughts into movement, and the person was able to kick. This is still not the end, because in actually this month, Scientific American, there's a new thing about the sensors and how sensors broaden our thinking. We can normally think about stuff that is relatively close to what our brain gives us input, and now with sensors, we can think a lot more. Sensors are everywhere. There's obviously traffic sensors and all kinds of stuff. I don't know if you know that. There's also shooting sensors. So there's, in New York City and all over the place, there's things like ShotSpotter that are just microphones that only listen to shooting. So if you're talking, they're not listening, because they delete that. So stuff like that exists. So there's public sensors that are put there to monitor danger or whatever. And if you look at the regular smartphones, the smartphone is smart not only because it has apps, but also because it has sensors. Without the sensors, you couldn't operate it. The first smartphones had 5 sensors, 3 screen sensors, 2 motion sensors. Then sensors got cheaper, smaller, faster, and even when Steve Jobs was still alive, they added gyroscope, accelerometer, compass, proximity sensor, ambient light sensor, and stuff like that. If you have a modern smartphone, it has 15 sensors. How good are those sensors? The M7, which is the motion sensor, knows when you're walking, running, driving, riding a bike, whatever. It knows a lot of stuff. Fire is coming right now. Fire has another sensor that is called Firefly. And Firefly is a really good sensor because if you just push Firefly, it will tell you what this thing you're just taking a photo of is. So it can identify objects like books, movies, and games. Why can it also identify movies and things like that? Because it doesn't only take a photo, but also audio information. So when you push Firefly, the camera and the microphone is activated, and the phone is too small, so they send the data into the cloud, where there's basically endless computing power. So the cloud computes everything and finds out exactly what you're looking at, what you're taking a photo of. The interesting thing is that that is not only the Firefly button, because the camera is the exact same button. So whenever you take a photo, Firefly is activated, sends a soundbite and a photo to the cloud, so Amazon hears and sees your environment. Which can be really good, because if you take lots of baby photos, you probably are interested in diaper advertising. If you go hiking, you probably like, I don't know, those bars or whatever, or hiking shoes, you know? So Amazon tracks your environment and can personalize advertising to you. We'll come to that in a minute more specifically. Smartwatch, obviously it will not look like this, it's just a mock-up, but we know all the sensors that it has, and it has 10. So plus the 15 of your phone, that's 25 sensors that you basically wear on yourself. There's a lot of services that those things can do. Skin temperature, for instance, I was talking to Webasto. Webasto is the air conditioning supplier for cars, and we were thinking, you know, sometimes, I don't know, I only know centigrade, so like 25 degrees centigrade is warm, sometimes it's cold, because on the skin it feels different. So the thing is, what they will do, they will use the information from your skin sensor to always optimize the temperature in the car so that it's always perfect for you. If you measure all those kinds of things, the machine might detect a certain deficiency. I'm not a doctor, so I don't know. Let's say vitamin B12 deficiency. And then maybe it would be good to actually mix goji berries into your muesli. So that's a good suggestion, because it knows that you need something, and it knows a natural way to compensate for that. So that would be a good service, because it helps you to actually improve the product. And in this particular case, this is a communication silo. The fuel band, or whatever that is, talks only to the muesli. In certain countries, as you might know in Australia, I don't know about the US, but then the Nike fuel band data is open. Is it open here also? So you can basically go to McDonald's and you can ask McDonald's, what can I eat? And if you did sports, they say, large fries. And if you didn't, salad. Only water, which is a good service. That's what your mom did, you know. You lazy person, here's a carrot. And then the boys come back from the field, you know, they should eat a lot. And that was just an information silo. And if you look at computers, they used to be information silos, and communication silos. So the computer communicated, say, with the printer, and maybe with 2 other computers in the room, but that was it. It was a silo, maybe 2, 3 things, but not really big. And then the silo was killed and became online. And the interesting thing is that in this today's world that we live in, communication, we think about the mobile phone, but communication is not only the device. It doesn't really matter if it's a phone that's mobile, or if it's, say, a bus that's mobile, or if it's the traffic that communicates. The communication is enabled because of the infrastructure. If you have an infrastructure, everything can communicate, not only your phones. So if you have mobile phones, you can also have communication between cars. And that means that you can really communicate, I'm going to stop, okay, I'm going to take a left turn. You know what we do at a crossroad, where we just look at somebody and negotiate who's driving? Cars can do that. Because the infrastructure exists. And the infrastructure is not only limited in today's world between the computer and the printer, but globally. So that's the internet traffic, that's a map of the internet traffic of the infrastructure. And we can access that infrastructure because we have browsers. And the first browsers, if you're old enough, things like Netscape and stuff were browsers. And MIT is now working on a browser for sensors. So that means if I look at this room, I see millions of sensors already that measure temperature. Is it burning or not? Is there fire? Is the air clear? How's the humidity? All those kinds of things. And with MIT, I can access those sensors. I have access to those sensors, and I can browse them. And if you do that, that will change everything again. If you now look at Google Maps, if you look at a regular map in a book, it can't do anything, right? If you look at Google Map, at least you can find certain places, and then you can switch to the sensor in the sky, which is the satellite. Ah, that's how it looks from the top. Oh, that's how it looks in Street View. Awesome, that's how other people did it. But now you still do not know more, because this is an old sensor picture. It's not real time. But if you have access to the sensors, and you can actually have a sensor browser, you can find out how many people are in this restaurant right now, the noise level, the temperature, and humidity. And if you want to buy that building, you can probably find out about the energy consumption, if there's certain leaks in the pipes, all those kinds of things, because you have access to those sensors. And if you have access to those sensors, you can broaden the input that your sensors have. We are limited to light waves. So New York to us looks like this. But if we were not limited to light waves and we could see X-ray, it looks like this. And if we could see radio waves, it looked like this. And if we can say infrared, it looks like this. So you can just broaden the scope of input that you have. You can see things and detect things that are really hard to detect. We're currently in Los Angeles, and I'm from Austria, so my skin is really sensitive to the sun, so it's really good that June exists, which is a UV tracker. It tracks UV rays, which I normally cannot detect. And it tells me what sunscreen I should use. It tells me currently on my machine or on Google Glass. And I could be in Manhattan Beach and understand, oh, and now I have to wear sunscreen factor 8. And that's a convenient information, because, again, it's a trade data for information. Data for service. The problem is, that's what I said here, you have to look on your phone, or you have to use Google Glass, and when you look at Google Glass, you don't look here, you look there. So that means operating objects takes attention, and we cannot concentrate really on the beauty of the image. And if you're driving a car, operating objects, even if it's completely integrated, like what Audi does, in your field, and you have basically just things where you have to go like this, it takes a lot of time to operate those buttons. And the interesting thing is that even if it's voice-controlled, we communicate with the object. So even if it's a voice-controlled change of destination and destination entry, we look 30 seconds at the object, because we're talking to the machine. Is it calculating it? 78%, yay. You all know how many percent it's calculated. Why? Because you're not paying attention to driving. You're paying attention to the little idiotic number that says if the thing is calculated yet, and how long it will take to get there, and what's the time when you arrive. So you're looking at that machine, which can be very, very dangerous. So even programming something by voices costs a lot of time. So the holy grail, what everybody's now fighting for, is attention-triggered input. Attention triggered is relatively easy. If I now invite you to pay attention to your breath, you now know that you're breathing. You didn't know it a minute ago because you didn't pay attention to it. So attention triggering means that just by thinking about something, you single that information out and you make it important. And our brain, although we cannot regenerate limbs, we can reinvent our brains and ourselves. If you're a bat, obviously you don't see rays, but you have sound. So you yell a certain sound, and then you see a picture that's generated by sound. That also works with humans. Human echolocation allows people to see without using their eyes. So it's a little sound machine that shoots out a sound, and then it comes back, and then your brain computes it, and at one point you see a fuzzy picture.
Ladies and gentlemen, ladies and gentlemen, ladies and gentlemen, ladies and gentlemen, your attention, please. Your attention, please. Your attention, please.
And now the moment we've been waiting for is here.